Hey man, you gotta come check this out.
I'll be right there.
Take a look at this.
Whoa. This is going to change everything.
Invite Alex. Hey, are you seeing this?
Whoa. This really did change everything.
Welcome back. I hope you enjoyed that video. I wanted to give you a sense of where Altium's come from, where we started, where we are today, and where we're going. And with that, I thought we'd actually start this keynote with a little history lesson on where Altium itself came from. And it's an interesting story, not too dissimilar, with one key exception to most technology companies that you'd be familiar with, and that is really where we started. Tasmania, Hobart, Tasmania, Australia. It is a remote place and certainly not the epicenter of electronics or EDA, as the slide says. It's a remote place. It really is an interesting place, a beautiful place, but certainly not a place where you would have expected an EDA company, and certainly not as successful as Altium EDA company to have started. The story is the founder was going to school at the University of Tasmania and was doing work, doing layout, doing electronics design. And in those days, there was a real disparity, an inequity, if you will, between those that had funds, that had money, and pretty much everybody else. If you had money, you could certainly spend big money on some machines, workstations that would facilitate graphics design or layout, primarily of printed circuit boards. And if you didn't, and if you weren't a big conglomerate, big organization, then you were relegated to really tape and mylar, light table, tape and mylar, and Bishop graphics. But our founder really saw where we had come from when we talk about Moore's Law and where we were going and what was going on at the time, and that's with the PC. The PC was coming into its own, the clone market was beginning to take off, and he foresaw that computing power would become quite ubiquitous. And of course, here we are today, and computing power is ubiquitous. It's everywhere. In any case, he had the idea that, well, maybe I could just write something for myself on this thing called the personal computer. And that's exactly what he did. Now, the interesting thing about that endeavor is that he actually didn't write the software with the intention of becoming a company. It was purely for himself. And I'd say that those humble beginnings and that sort of focus on the user comes first, in this case it happened to be him, has really stuck with us, and it's really stuck with us today. Even though he didn't write the software with the intention that it would become a business, it did. And over the years, we've put into the market space some industry firsts, quite a few of them actually. Obviously, one of the first on PC, one of the first, well, the first EDA or printed circuit board design software on Windows way back in 1991. In 94, we had the first platform for unified PCB development, first product for unified PCB development, the first product for unified product development. In 2006, we released the first 3D printed circuit board design software, native 3D printed circuit board design software, and first rigid flex solution for printed circuit board design back in 2014. And the reason I bring these up is certainly not to brag about all the great things that Altium's done, regardless of whether we were known as Protel or Altium. It's really kind of set the stage for what we want to talk about today, and that's where we've come from and where we're going. And we really want to put into perspective for you the things that you guys have asked for, need, want, and desire in the product, as well as the things that we're putting into the product that are also industry firsts, once again, and where the market will go and how we're going to transform the market as we've done in the past. And I'll just give you a quick example of this. So in 2006, so this would have been October of 2005, that's actually when I started as a humble salesperson working with Altium in Rancho Bernardo, California. Small little office. I remember there was koala bears stuck on all the cubicles, and I started the first day. I said, what have I gotten myself into? In any case, in those days, in that time frame, in October of 2005, we were selling upgrades to our latest version, which was Altium Designer 6. And as a salesperson, obviously you want to find the killer feature. You want to find the thing that people really respond to, that compels them to want to purchase the software. And in that day and age, it was this feature that you see on the screen. Now I've recreated it, but this was the feature, and it was Flipboard. I'll never forget the shortcut keys. It was VB. If you hit VB, I think it's still in the product today. It would flip the board, and the magic was that it would flip the board, and you could read the text in the correct direction. It wasn't inverted. And this, I mean, you'd mentioned this, and people just went crazy. They said, absolutely, I'll upgrade. Here's my credit card. I'll take it. And I sold, I'll never forget it, because there was a bonus on the upgrades we sold. I sold 35 of those upgrades that first couple months on the job, and I was quite proud of myself. But it was on the back of this feature. Now, about 6, maybe 9 months later, 6-9 months later, we added this to the product, which was we took the PCB editor and added 3 dimensions to it. And seemingly you would think that this was a raving success, but it actually was not. I took many hostile phone calls from many customers that suggested that we were wasting their, in those days we called them maintenance dollars. Our competitors went as far as to really actively market against it, saying that it was a gimmick and that it was really a toy and that it would really amount to nothing, and real designers need what we have versus the gimmick of 3D. And obviously the point I'm making is that we have to balance the things that you guys absolutely need, want, and desire to accomplish your jobs today, but we always have our eye on what's coming next, and we try very hard to bring it to you, okay? Now, oftentimes I like this phrase where we say what leading is. What leading is sometimes maybe taking people to places where they don't want to go, but if you've been successful once they're there, they never can imagine going back. They'd never want to go back. And I think this is really one of the fundamental reasons why I've stayed with Altium all these years. We're always willing to push the limits. Yet we always maintain that focus on the user. So those innovations are always really pushing the limits for you, the people that actually use the tools. But we're also trying to push the limits. And we'll talk a great deal about this during this keynote when we talk about now expanding your influence from just the design domain to now these what we call secondary stakeholders when we talk about the supply chain, fabrication, and manufacture. So when we talk about the things you need, want, and desire, well, quite frankly, as well as future proofing, if you will, the things that we put into the software for the future to transform the industry, we obviously have to look at industry trends. Now, this is a slide we've used for some time. I like it very much, but the purpose here is to show this ideation to realization cycle. And I tell this story often. When I got into design work back in the sort of mid to late 90s, I didn't do anything overly sophisticated. I was in the audiophile market space. We designed power amplifiers, but it took us a year to design a power amplifier. And obviously a power amplifier is not exactly a secret on how they work. It was mostly designed by ear. We would experiment with different components, different transformers, different brands of resistors, transistors, tubes, op amps, all those things. But it took us a full year. Then fast forward to when I got into the semiconductor business. This would have been in 1999. I remember I got the job. They said, there's your desk, there's a phone, and there's a phone book. Have at it, have a ball. And they said, oh, by the way, don't expect to make a dime for 2 years. And of course, I didn't get into that business because I didn't want to make any money. I was curious about that. I said, well, why want to make any money in 2 years? They said, well, the customer's design cycle. Well, first, most of the designs your customers work on will never see the light of day. They'll never go to manufacture. But secondarily, if in fact it does make it to manufacture or realization, their cycle's 2 years. 2 years design cycle. And almost to the day, I didn't make a dime for 2 years at all. But if we look at what we have today, we see a significant increase in the velocity of the design cycle. We see people that are designing multiple designs, multiple circuit boards each and every month. And this really tends to be more the norm than the exception these days. Another trend we pay close attention to is what I call this, well, it's a combination of things. It's the growing design complexity, as well as this need for engineers and PCB designers to be all-purpose. In other words, more and more you guys are all being asked to do more and more things. It was rare in the semiconductor business that I would get an opportunity to talk to an engineer or designer about anything other than the most sort of sophisticated and most sort of rare devices. If it was what I would call a popcorn device, they weren't interested. But those design decisions absolutely had impact when we talk about lead time, pricing, second sources, all those sorts of things. But those responsibilities have all been saddled onto all of you fine folks. And if we look at this survey information, we talk about design complexity. When I first got into the business, a gigahertz was an exotic design. If you had a data rate that was a gigahertz or more, you were really pushing the envelope. I mean, you were really a rocket scientist. And nowadays, that's common. 50% of the people we survey tell us that they have at least a gigahertz data rate. And this is accelerating. Likewise, we talk about this more sophistication being added to the design process. As these design speeds or these data rates increase, it's forcing more and more of those design responsibilities, PCB design responsibilities, to be absorbed by electrical engineers. And when we survey our customer base, only about 14% of our customers today have a title of printed circuit board design. The rest of them are, in fact, electrical engineers. Now, what this has also done is really forced PCB designers to become more like electrical engineers in their own right as the PCB design side of the house becomes more and more sophisticated. Now, we talked a little bit about in the opening the phenomenal success that Altium's had. And as I said, that's really on the back of all of the things that we focus on. It's you guys, the customers, the users of the software. It's rare that we speak to a director. It's rare that we speak to a vice president. Overwhelmingly, our salespeople, our account managers, our technical folks are 100% aligned with really talking to the users and therefore the buyers, as far as we see it, of our products. And with that, really, we're put into a position to really focus on this concept, what I say is the user imperative. We're now in a position where we have more to lose than we have to gain. To me, the linchpin in maintaining that success and maintaining our number one position is making sure that we take care of all of you. And over the past year, we've done a lot of things. Increased our focus on the bug crunch, really focused more on trying to be more reactive. When we do get bug tickets or when customers call for support, we've really invested heavily in that. And I'm proud to say that as of October 5th, Monday, October 5th, that now we have 130, a little bit more than that actually, 130 agents available on our website for all of you. And this is the entirety of our real customer-facing workforce. So our salespeople, our applications engineers, our technical salespeople, pretty much the entire organization is available to you now 24 hours a day, 5 days a week. And I'm talking about a live person. Likewise, you can now do all of your purchasing. So if you want to renew your subscription, you want to upgrade from a standard subscription to professional subscription, you want to add licenses, you can do all of that now online on our website and talk to a real person if in fact that's what you choose to do. Now let's get into the meat of this. This is the bit you probably came to see, which is to talk about what's coming in 2021. And likewise, I want to kind of take you through a tour of where we came from, where we are and where we're going. And that'll be the theme of really the rest of this portion of the keynote. And the first thing I want to show is I think we started to do this a bit more last year, which was to really talk about the development arc of our products and really kind of put into context. I think we unfortunately had a habit prior to last year of really showing you a feature, but not contextualizing how we ended up there and what it means down the road. And in most cases, all of the things you see are investments. Some of them are long-term investments, some of them are medium-term investments, but my hope was to put this into perspective for you to give you a sense. So if you look at the x-axis here, that's obviously representing time, and the vertical axis here representing really the magnitude the magnitude of the investment we're making by functional area of the product. And I think for me, when I saw this, it really sort of put in perspective the sheer amount of work, which you have to realize is this is all we do for the most part. Printed circuit board design is what we do, and it shows. I think if you look at our products, by far the best looking products in the industry. I think by far the most user-centric products in the industry, and certainly the products with the most focus on the user, and exclusively really PCB design. Give you a little more depth here when we talk about those investments. You can see now in a little more palatable way kind of the duration of those. So for example, performance. Performance has been a long-term investment that we've made, and it shows. So in 18, we pivoted from 32-bit finally to 64-bit. And then last year, really the star of the show last year was interactive routing. And what you can see is obviously a significant amount of investment. Now at the very bottom, good example here is an investment we made. It was an industry first. And we haven't made much of an investment in recent years, but that's now changing. And there's a couple examples of that as we go, and I'll show them to you. Okay, so first and foremost, performance. Really our goal is to be the highest performing product in the industry, regardless of the scope of the design. Large designs, small designs, we really want our products to be the fastest, the quickest, the sort of smoothest, the slickest products out there. And the feedback we're getting now is that for the majority of our users, we're already there. But really where we are now in this development arc is really focusing on those corner cases and really getting at those really, that 1%, if you will, of designs that are really sort of pushing the envelope. And that's our focus when we talk about performance. Now, a feature that I'll show you that you should expect in 2021 is a good example of one of those things that you guys have been asking for some time. And I'm actually very, very pleased. When I saw it, I was excited to get to show it to you, and it's this. Now it's called dynamic polygons. So the typical process that we would go through, and you guys would know this more so than anybody else in the world, if you needed to alter a primitive that had anything to do with a polygon, it was basically route, repour, route, repour, route, repour in this particular example. But we now have dynamic polygons. So effectively the performance now is so great that it dynamically repours as you alter those primitives. This is something I would suspect if we were at the live event, which unfortunately we're not, this would be one of those applause moments. I know this has been a long time coming, and we're very pleased to be able to bring it to you. So interactive routing, as I said, star of the show last year. This was the applause moment. We now believe that we have the best routing experience in the industry. I feel pretty confident in saying that. The feedback we've gotten from the user base tells us so, but that's not by accident. If you look at the duration of this investment, back in 2015, we actually went and sourced and hired a brand new team specifically just to focus on interactive routing. And it really shows. So the sliding capabilities you all saw last year, some of the things we'll talk about like tune for delay, but this year we're introducing some new interactive routing capabilities, some more fit and finish, spit and polish, if you will, that'll give you access to some more high-speed capabilities and just really more tools in your toolbox. And when we talk about high speed, what we see is more and more users looking to use Altium Designer on high-speed designs. As I said, about 50% already have speeds of a gig or greater. This investment, what you've seen, started sort of quietly in 2019 when we introduced the field solver, which brought us the materials manager. Then we built upon that tune for delay. We put return path checking in there. But what you see, if you look to the far right of this slide, is it's not just about routing technologies. Okay, if you look through there, where we're really taking this is really into an SI domain, into a signal integrity domain, but in a very Altium way. Altium is quite famous for what I call democratization of high-end technologies and bringing those to the masses and really making those technologies accessible. So what you'll see further down the road would be what we call in-design SI, so very analogous to like an online DRC, where as you design, there's a solver in the background that's working to flag potential signal integrity issues that you might have. But as far as interactive routing capabilities that you'll see in the short term, we've got a few. And this is one. So we now have trombone. So this is great if obviously you can see in this example there's a tight space, but yet we need to add quite a bit of length for that signal to arrive at the same time. This is net length with trombone. So this is what you can expect in 2021. Likewise, we now have sawtooth. So there's some sort of pushing the limit, high-speed design applications that would use this. But yet again, just another tool in your arsenal of interactive routing capabilities that we're bringing to you in 2021. We had specific customers that were asking for this, and we're happy to bring it to you. And really now where we are with our interactive router, it's really like just every new feature just takes it to the next level, to the next level, to the next level. And this is, as I said, something we're quite proud of, the interactive router as a whole. And we're happy to bring you these capabilities. Now, schematic. Schematic is an area where, quite frankly, we haven't done anything in like 10 years. Last year, we did begin to make some investments, and you would have seen those in the DirectX capability, the dynamic DirectX capability on the schematic side, as well as the dynamic compilation. So we removed the compile button. As I said to all of you last year, that was really more scene setting for where we want to go with this. Okay, and where we are going with this is really to enhance the rubber banding capabilities, so the broken wire stuff that some of you guys have told us about that we're very well aware of. Also, generic components is coming in the very, very near future. So instead of having to use an actual library component for like a resistor, you can just place a generic resistor down and keep on going. You don't have to stop and be bogged down by that. You can come back to that later. So that's a feature that people have been asking for that we're quite pleased to bring to you all as well. This is an area, constraint manager, where again, lots of people have been asking for this, and that is the long-term goal, and we ultimately will get there. In the short term, what we're adding is really a new ability in visualizing your rules. Okay, so in 2021, what we're featuring is an alternative to create and work with your design rules. So in this new mode, it allows you to add all critical design elements, components, nets, your low voltage differential signals, etc., and visualize those rules all by that sort of class of component or net class, if you will. So it's not quite full constraint management. It is currently only on the physical side, on the PCB design side, but do know that constraint management in the way you would all be familiar with it is coming. In the short term, a much easier way for you to deal with your design rules in a single user interface, as you see here on the screen. SPICE simulation, another area which a recent development. Last year we introduced a new SPICE engine, and as I said, scene setting. That was the beginning of this investment. And really what that brought was the ability to really use models. Our old Spice engine had really kind of run out of gas and had really limited ability to accept models. And so what that means is most people now are not using the simulation capabilities in Altium Designer. But I promised you that would change, and here we go. Our goal is to make our Spice engine, our Spice experience in Altium Designer first class. And I mean not first class, but best in class. The best in the industry compared to anybody. And in the short term, what you'll see is the ability to accept even more models and a new user interface. So what you see here is a couple things. If you look at the right-hand side, we're looking at a voltage source. Previously, our user interface for Spice used generic components. Those were just components. And they really weren't specifically suited for simulation. So now what you see here is actually a dynamic representation of, in this example, that voltage source, the period, the duration and the amplitude, I should say, of that voltage source. And that will change as you change the parameters below. So you get a real representation. It's a meaningful dynamic representation of what you're putting into the simulation. On the left-hand side, however, is what we call this new simulation dashboard. And this is really a 1, 2, 3, 4, no learning necessary approach to Spice simulation. So quite frankly, our goal, our aim is for anybody be able to pick up the tool, click on the icon for simulation, and really be able to get through it with almost no documentation. And once you see it, I think you'll be quite pleased with it. This is an area where we're quite excited, and we know a lot of customers are excited as well. A lot of customers using third-party products right now. We're very happy to finally bring that back into Altium Designer. So you're only drawing one schematic, quite frankly. Rigid Flex. Rigid Flex is another great example of something we did first. It got a lot of attention. I remember we won an award. I presented it at DesignCon, and we won it's still called the Design Vision Award in 2014. It was for this capability. It was a bit ahead of its time in that Rigid Flex in those days was still not widely used. However, our analytics show that currently about 2 times as many users just with Altium Designer are actually using Rigid Flex than they were back when we first put those capabilities in Altium Designer. This is also another capability that was copied by the industry. I think this is a good example of us sort of looking ahead and bringing you something before you needed it. But now we definitely see the mainstream of the market is really needing this. And what we've done is really enhanced it in a meaningful way by bringing this, which is a new, more realistic stack-up designer that allows you to really work with the modern materials, modern technologies that are available today. There are certain materials in a stack-up that are relevant only for flex stacks, like cover lay, adhesive, stiffeners. Well, AD in 2021, Altium Designer in 2021 now features predefined layers for these flex stacks that now have their own specific behaviors and visual representations. This will allow for more complete and realistic physical model of your flexible PCBs. Also what this allows is now this ability, in this particular example, of selective bonding. This was achieved via a changed approach to the flexible and rigid regions, which now, instead of being formed through general partition of the board outline, are now created as individual zones that can be edited independently. This allows overlapping zones that can be bent with different bending radii, if you will. So like a bookbinder. So in this example, what you see is you see 2 rigid sections, or flex sections that are bonded together and overlapped, but now able to be bent in opposite directions. Quite frankly, where we're going with this is we really want you to now be able to tackle any modern flex or rigid flex design, and that's what you'll see in 2021. Now we get to Altium 365, and we're going to bring some gentlemen out onto the stage with me, and we'll do a bit of a discussion about how they leveraged Altium 365 in their open source Ventilator project. But you can see this has been a long-term, even though it's just recently been made available to the masses. This has been a long-term investment of ours. And some of the new features, if you're not already using Altium 365, I encourage you, if you are in fact a current subscriber, you are absolutely entitled to use it. All you need to do is set up your workspace and begin to use it. I encourage you to do so. And this is also, of course, an area where there's no lack of investment. And the newest things that you'll begin to see here is this design history. This is really something I'm excited about because it really puts this concept of collaboration on the forefront. And what it allows you to do is really visualize everybody at every sort of milestone or check-in, even an MCAD exchange in this particular example, really visualize who and what actually happened. So this is really exciting actually. Not only that, but now what you're able to do is actually click on any stage of that project and simply click on another stage of that project and get a full graphical comparison of the differences between those two. So this is very exciting. We're going to spend quite a bit of time talking about Altium 365 in just a second. But to talk about the trends that we see, and this is something I think is very well established, and you'll hear the gentleman, I believe, talk about this when we bring them up. I think it used to be that PCB designers, when it was a trade of its own, it was a profession all to its own, PCB designer. Those individuals tended to be very, very close to the manufacturing elements. Also, way back when, obviously, a lot of the manufacturing was done in-house. And so what you had was PCB designers that were designing with a strong awareness of what actually could be manufactured. As this trend of engineers coming into the industry, taking over printed circuit board design responsibilities, there's a growing divide between the designers and the engineers. And this is something when we talk about connecting the primary stakeholders, in our case, users, all of you, PCB designers, electrical engineers, to the secondary stakeholders of supply chain and manufacturing. This is really where Altium 365 shines. And this is what we're going to bring these next gentlemen out to discuss right now. All right, without any further ado, let's bring out our guests. I'm going to switch sets and I'll bring our guests out and we'll be right with you. Thank you very much for your attention and we hope you enjoy the rest of the week here at Altium Live. All right, welcome everybody. Welcome guys. As promised, I'm bringing some special guests to the stage right now. Everybody should remember Leigh Gawne from last year. Leigh Gawne is Altium's chief software architect, and we're very pleased to have Leigh. He's done some really outstanding things for us. I'd also like to invite Dugan Karnazes. He's the CEO and founder of Velocity Research, a service bureau up in Michigan. I'd also like to invite Rob Cook. Rob Cook is the Director of Engineering Services at Calumet. Calumet is a fabrication house in the Upper Peninsula of Michigan. And we'd also like to invite Chris Denny. Chris Denny is the CTO of Worthington Assembly, which is an EMS provider in Massachusetts. And we're very pleased to have them. These gentlemen were deeply involved in bringing to life the open source ventilator project, which you may have seen us post on some of our social media channels. We've done a great story. If you haven't seen it, go look for it. It's a hell of a story. Likewise, we're going to be doing a panel discussion with these gentlemen on some of the more intimate details of how that project came to life. Today, however, what we're going to show you and discuss and highlight for you is how these gentlemen leveraged Altium 365 to bring that project to life. So gentlemen, thank you very much for being a part of Altium Live 2020 and welcome to the stage.
Thank you for having us.
Pleasure.
Yeah, it's great to be here.
Good
So
to
with
be here
that,
again.
oh yeah, Leigh, it's always a pleasure to have you. And it feels like we almost never speak. So Leigh, perhaps we start with you as obviously the architect of the product. I know you have some real insights, and obviously I think you're very pleased with what these gentlemen were able to achieve. Not just these gentlemen, but a larger audience, or I should say a larger collection of engineers and service providers from around the world. So with that, I'll let you take it away, Leigh.
Sure, Lawrence, thank you. So, I mean, this time Altium Live, we were just launching Concord Pro on Altium 365. And really, we've had a pretty solid year. In May this year, we actually went public with 55 to the masses, to the entire subscriber base. So it's not just been those Concord Pro customers, but literally everyone in the user base now has access to 365. And the growth really since the beginning of May has been nothing short of phenomenal. I mean, week on week on week, we're having more and more and more of our subscribers come to it. Now, obviously, given the situation that we're in today with COVID, the kind of forced remote working and so on, I think Altium 365 has really come through and shone for many of our customers who were, in a tricky situation in many cases. And, the guys, as you mentioned before, with the open source Ventilator project have really taken 365 on board, kind of what fabric of what they've done. And we're going to talk a little bit today about, how 365 has really helped made not only what they've done possible within the kind of time frame that was pretty critical given the circumstances and the project they're working on. So today we're basically just going to go through, and like I said, last year we kind of stood on stage, we did the demo, we had everyone inside Altium. You remember that? We had our French people, our Spanish guys, our German guys, basically showing how 365 really could be used to collaborate. But of course, that was an internally driven thing, showing you what Altium 365 could do. Now, this year, what we're showing you is what Altium 365 not could do, but has done and is doing every day for our customers. And so, I'm really, really pleased to have the opportunity, obviously, to walk through that with these guys today. And for some of this, it will be new for me, actually experiencing and learning about some of the things that they've done. And, hopefully interesting for all of you watching as well. So maybe we could just kick it off. I guess my first question to Dougal might be, how did you discover Altium 365? How did you actually come to find out about it?
Yeah, well, the first time I saw 365 was at the conference last year, and I will never forget everyone with their hats and different country-specific garb on, going through and doing the demo. And
we were gonna wear those same outfits too.
Yeah, we really considered it. Yeah, that's I think that the hat equivalent for Michigan is just a big glass of beer, but yeah. So
bratwurst, or is that more of a Wisconsin thing?
Oh, we like them here too. Yeah. But yeah, to answer your question, saw it at the conference is that, that is phenomenal. And at the time I was working for a large global company, and I could see us using that kind of thing. But then later on, I left that job to start Velocity, and honestly just reached out to Judy and said, hey, I'm starting this company. I'm just getting my feet wet here. Is there anything I can do to get involved with this? And she said, well, if you feel like writing some articles for you, we can probably get you in the beta program here. And from there, it was smooth sailing since, and I got to see all the features develop in Altium 365, and I've been using it at my company really since the beginning. So it's just our way of doing things. And when it came time to apply it to the open source Ventilator project, I kind of had the advantage of already being familiar with the platform. And I was like, oh, we need to tie together tons of engineers from all over the world. This is, in my mind, the only way to do it. So yeah, I got a sneak peek of it early and knew how to use it. And that's how I wound up being on the open source Ventilator project.
You mentioned there that you had literally engineers from all over the world that you kind of needed to bring together, and Altium 365 kind of being that global platform, tick one of those boxes and solve one of those, I guess, problems for you. Could I ask a little bit about, just rewinding back, how did you assemble that team? How did you, come to have all of those people needing to come together on this project? Can you talk a little bit about that?
Yeah. So again, when I joined that project, I thought I was just going to design a circuit board, or maybe a couple circuits in a circuit board, because there were so many volunteers for it. What I quickly realized was, especially Chris, you probably remember the early days on that Slack channel. There were hundreds of new members coming on each day, all saying like, hey, I have this background and this background, and a lot of really qualified and really energetic people. But yeah, we realized kind of quickly that there was no shortage of manpower, but what we really needed the most was organization. So,
well, Dugan, how many people, just curious, how many people did you end up assembling to work on the project that actually contributed services or work to the project?
I don't even have the numbers for the full project, but I can speak for our team. When I initially sent out invites to 7 engineers, I had a spreadsheet of 800 people across the globe to choose from. And from there, and that was just at that point in time. And then more people kept filling out the Google form to volunteer their efforts. And what I did, Leigh, is we sent out a Google form that asked for your experience, your availability, and like what tools you were familiar with. And I sorted that by who was highly qualified, who had time available to actually work on the project, being greater than 15 hours a week, and who knew Altium. And that is how I picked my dream team. And yeah, so as soon as I sent out all the invites, people were familiar with Altium. They were just learning how to use 365, and it was a very short learning curve for them.
Awesome, awesome. I mean, maybe we could even jump into just having a quick look. If you're able to kind of screen share, maybe we could even just take a look at that kind of team composition that we got there, and we can, you know, seeing is believing, as it were. Give people something visual that they can relate to as we talk through it. That'd be awesome.
Yeah, absolutely.
While he's bringing that up, you know, I was going to mention too, just, you know, I was introduced to Altium 365 at the conference last year as well. And it really was that, you know, potential to see what it could be like to collaborate across, you know, multiple different organizations. And it was intriguing at the time to see, oh, well, maybe this might work. But then when we actually started doing it, to really see the full power of it is really where it kind of blew your mind.
Yeah.
Awesome.
While you were looking that up, I took a minute to see how many people were involved in the open source ventilator project, and just in the Slack channel, not necessarily directly involved with Dugan, but just in the Slack channel, there were over 2,500 members. There was just an enormous outpouring of support for the project.
Yeah.
Wow. Wow.
Yeah, and I also want to comment, we are one of the OSV teams, but there were a lot of teams working on a lot of different designs and even projects that weren't ventilators. So yeah, we're not speaking for the whole group, but it's fun sharing our experience with our involvement.
Absolutely. I mean, just looking at the kind of what you're sharing now, the team, I mean, there's a fair number of people inside your workspace here that you brought in to kind of bring together, right?
Yeah, so my company has 6 people. The other people here are largely volunteers for OSV, and then a couple other stakeholders on our projects here. But yeah, no.
How many of them ended up being actual designers, electrical engineers or PCB designers, Dugan?
About 7. 7 people were in there making those changes, and that was, we had volunteers from South Africa. Nadim Conti in Italy largely led a lot of the technical development and coordinating all those teams. And yeah, he's a nuclear physicist at CERN. He's a really, really impressive dude. And like the design that came together was specifically meant to be easy to assemble. So it's not highly complex from an electronics or manufacturing standpoint. But what was extremely sophisticated and impressive on his end is he pulled together a Google Doc, and by the time it was done, we had 80 pages of specifications for just how this is going to be laid out, and that's what the design team was working off of.
Well,
so,
we all know, Dugan, the simplest designs are actually the most complex.
I would disagree with that. Keep it simple, please.
Yeah.
All right, so so let me ask you this question then, and this is to really anybody, but it sounds like Dugan would be the closest. Excuse me. Is it safe to assume that everybody was brand new to 365, but probably had Altium designer experience?
Yeah, because at the time where I was roping them in, this was before 365 was even released. So yeah,
That's right.
Yeah.
when you talk about roping them in, I mean, how easy was it to rope them in? I think it's pretty straightforward, right? Literally like click a button, send a mail.
Yeah, no, the response was very enthusiastic because, again, like from our participant standpoints, as they're getting onboarded into OSV, they're like, oh, cool, I want to help out with this project. And then they're inundated with all of these Slack messages. And it's, yeah, when I sent them an email to be like, hey, this is the platform we're going to use. You came up in our search. Do you want to join? It was very simple. Now, the other thing that we had to do is I wanted to provide licenses to these people too. So the way that we went about it is within our admin panel, I created a new role for OSV. Then I added these members into the OSV role and gave them a license pool, and then just sent them an invite to the server, and they could hop on, they could get access to the design, they could get the license right there and run with it. And by that point, it was just using Altium and committing it back to the server. So yeah, it was, the onboarding process was really easy. And in my email, I said, like, if you guys have any trouble, just let me know. I never got, I never got any trouble.
Okay, that's really good. Really good to know. Awesome. All right. So, given the fact that that design was, you were starting from effectively a derived design, could you maybe just walk us through like how you actually did that with 365? Went from that just local project to something that everyone could collaborate on?
Yeah, it was really easy. So Chris Baird sent over his project file, and then to make it available online, all you got to do is open the project up right here, and then right click and make project available online.
Cool. So literally
Enabled version
right
control.
click. So the key thing here is that you're enabling this formal version control. So it's going to use the underlying Git based version control system.
Yep.
Sure.
Absolutely. And then, yeah, green check marks are there. It's available on the server. And then we just started adding people on.
All right, awesome. So maybe we could just quickly jump to the web browser to show people just how that kind of looks once you've,
Sure.
I mean, that took about 10 seconds and was a couple clicks.
Yeah. No, it was really pretty smooth. So there's the original one. Here's the one that we just did today. And what we did is went to share. Mm-hmm. And everyone who was on the OSV project, we just assigned to the OSV role. And the reason we did that is because this is like our company's server. And obviously we can't have open access to all of our client designs. That I'd be out of business overnight. Absolutely. So what we did is created the OSV role and hit share. And now whenever someone new comes onto the team, we just add them to that OSV role and they automatically have access to all the projects that go along with it. So yeah, it was really like, it was as easy as it could be.
Could you maybe jump to the roles and permission setup side of things, just to talk a little bit more about the kind of the role setup and what that means to people here?
Yeah.
Like you say, this is quite a good capability where it enables you to, instead of having to go through each individual user to give them, access rights to a particular project, right, you can effectively assign it to a role, right?
Yep. So here's the team panel, and these are where we added in all the different collaborators on the project. And then on the admin side, like Austin Gilbert, for example, our intern, I want to edit him. So he is both an admin, a librarian, and he's on the Velocity staff. But for me to add him onto the OSV team, it's just as simple as that. So he's able to see our internal projects and the open source ones. But other people, for instance, our friend Chris Denny here, Chris is only on the OSV team and he can't see any of our internal stuff. So that was really, really important for us to be able to do this kind of project with this platform, is being able to manage who has access to what portions of our designs in our whole repository.
So Rob is also on the OSV team. So maybe Rob could also just bring it up and show us his view.
So are you guys seeing my screen now?
We are.
Yep, we see it.
Opens up in this schematic and brings me right over to the PCB. I can switch to the 3D mode since that's what we were looking at before. And yeah, just like that, access. And really what happened is that it sent an email to me telling me that I had access to this server. I clicked on it, logged in with my regular Altium password since I'd already had an Altium account set up, and was in 2 minutes.
Mm-hmm.
That
Well, I mean, I was going to say, Leigh, if I could, obviously, shameless plug, of course, but I am the marketing guy. You know, I think this is just a real profound example of what we talk about designing with your manufacturer. And Rob, maybe if you could, and maybe this is a bit of a loaded question as well, but maybe contrast that with what you would normally, how would you normally work with a gentleman like Dugan in a similar phase of a design of a project?
usually we would just get Gerber files only, which would eliminate any of this ability to see kind of what the surrounding components are going to look like. And the other thing with the OSV design is we could see where this board fit in the overall stack of boards in the entire assembly, which both from Chris's perspective, I think, and my perspective, it does make a difference to see that, because we can see, oh, where are some things that we could get, you know, from similarity. Even in board materials, we could find ways to get the stack up uniform and have a higher level of bulk material purchase, which saved us money and saved Dugan money, you know, in this future design and build, right? So it's kind of a really incredible tool to be able to have that at your fingertips. Whereas normally I would get maybe a fab drawing. If I'm lucky, at this point in the design, fab drawings might not even be done yet. I can take measurements, which I did. I figured out what our panel layup was, and how many we were going to be able to fit, and was also, you know, we didn't have to for this, but I could say things like, oh, if we could shave 1/8 of an inch off in this direction, you know, we could fit 20 more parts up on a panel and, you know, drop the price in half.
Well, that's a question I have for you. Again, if I could double down on that one, which is how many designs do you get that are actually, that you're actually able to panelize in an efficient way right out of the gate from your customers?
We have a few customers that are pretty intimate with us and they understand panel sizes, but the large majority do not. I mean, I would say it's like 90-10. And even when people start understanding panels, they don't understand keep out areas very well, even when we try to put that information up on our website for all to see. And to a certain extent, they only have so much they can do for panel efficiency, right? They're trying to fit stuff inside of the front dashboard of a Humvee or a JLTV or inside a missile system. The shape is going to be what the shape is. But having some understanding of that does make it a lot more viable for us to produce. And then when we get involved with like Chris's team, we have to put rails, because I think Chris said, you know, earlier, we never assemble them just one at a time. We usually assemble them in arrays of 3 or 4 or 5. And so even making it so that we can have an array that's going to flow through the reflow oven or through some of the other select pick and place processes in a lot more efficient and smooth manner is beneficial for us to see that early on.
Yeah, and we're going to need, you know, we're going to need waste material around the edges that we can break away when we're finished. We're going to need fiducials added, tooling pins, all these other things that normally a designer never has to think about. So it gets pretty complicated.
So, Dugan, maybe we could just also show our guests the invitation process here.
Yeah.
If you wouldn't mind, maybe just invite me to your workspace, and I can also just quickly show them, you know, how straightforward this is when you want to start assembling your team and adding more people to it.
Yeah, absolutely. So all I need is an email address.
All right, I'll just ping it over to you magically. There you go.
Got it. Okay, so let me share my screen here. And is this coming through?
Yes.
Yeah, we see it.
All right. I'm going to invite Leigh, throw him on the OSV team. And you're not in my organization, so I get a little warning about it. But
That's a good thing, just in case you copy and paste someone else's email, just to make you aware that you know, I'm not necessarily in your inner circle.
Yep. So invite sent.
All right, cool. So maybe I can share my screen here. So here we have my email from Dugan, my invitation email. So I'm going to click the accept invite button here. And it's going to take me into my login. I'm just going to log in via. And by the way, if I didn't have a login here, I could quickly register or even sign in with my Google or Facebook account. It's really straightforward. So if the person that you're sending this to has obviously never been to Altium 365 before, which Dugan, I'm guessing a few people would have been like that. It's a pretty straightforward thing to.
Well, yeah, it was unreleased, so everyone was seeing it for the first time.
Yeah, so they absolutely would have gone through this.
And Leigh, you don't need a license or anything to have access to other people's designs like this, right?
Exactly. No license, no AD license required at all. So here we go. We're in Altium Concord Pro on Altium 365. That's the name of Dugan's workspace. And you're right, to access this through the web browser, this is completely free of charge. So you can invite as many people as you like to this to interact with your design. So again, we're just going to click on projects here, and there we go.
Yeah.
Projects here. And
So
there we go, the open source ventilator demo one.
Yep. And that was the one we made today, but of course on the OSV team, we made a few other designs too, and you have access to those in the same group.
So everything just within there. Yeah, I can see there's actually quite a few designs in here.
Yeah.
All right, awesome. Okay, so Dugan, maybe we could talk a little bit about the component library side of things. I mean, obviously having, component libraries are fundamental to maintaining kind of good design, especially when you're kind of working across, multiple people. What was your kind of like approach to component libraries here? Were you kind of using more traditional libraries, file-based, or did you use the managed library concept within Altium 365?
Yeah, so on this one, I forced people to use their own libraries because I really didn't want a whole crew of people all over the world messing with our internal component library and structures. So again, everyone was coming on already with Altium experience. Many of them already had the libraries they wanted to use on their own.
Mm-hmm.
So yeah, on this project, everyone used their local libraries or made it themselves. We didn't use the Concord portion of 365 on this.
Right. Okay. Cool. How about just in kind of from the day-to-day business of Velocity? You mentioned you obviously are using the kind of managed libraries. Could you maybe talk to that a little bit and just how you're getting on with that? What's your experience with that?
Yeah. So this is really interesting because in the scope of when I've been using 365, when I first started, it was just me, and I was using like a collaborative environment, but just with one user, and it really allowed me to stay in sync and just keep a good repository of all of my designs. But then when I started adding people, it became so much more useful. Like when we hired our first electronics intern, he like knew how to operate Altium, but was still learning the right ways to design a board. You know what I mean?
Yeah.
So it started off where I didn't want him creating components yet. I wanted to like kind of teach him our process for doing that. So when he needed a new component, I said, just submit a parts request and I'll make the component for you for now. And then I'll like show you how we do our footprints, how we apply templates, how we do the schematic symbols and all of our standards there.
Okay, that's pretty awesome. So you touched on two things. Like one thing there's specifically the part request side of things, right? Did you use the part request capability inside Altium 365 for that?
Oh yeah. Yep.
All right, cool. Could you maybe show us that? I think people, because this is one of these features that is, not often talked about here, but definitely quite a powerful way of coordinating people when it comes to, like you say, making sure that we're following a process when it comes to part creation and things like that.
Yep, absolutely. So like I find examples are always done best in the case of a story. So recently we had another engineer coming on. He's learning Altium, but he's a very experienced engineer. And again, I didn't want him to mess around with trying to figure out how to make parts the right way. But now Austin, our intern, is much more proficient at making parts and actually helped write some of our standards than like just get it all down on paper. So what we had Ben do is through the web browser, you just click on parts requests and add a request. And yeah, I got some other ones in here. So there's a Phoenix contact part. There's always start with like 008, something, whatever. And you can say when you need it by, and this one is, well, pretty hot. So let's say we need it by today. And we're gonna assign it to Austin. And this component type is, I don't know. Nope, we're doing a connector, aren't we? So where are my connectors? Well, we'll just do a Phoenix contact transistor for the sake of this one, but you get the idea. Like you go through and you select what kind of component you're making. That help tells Austin what's going on. And then if I want to, I can go through and attach the data sheet. So you kind of get the idea. As soon as you save that, it sends an email off to Austin with all of this. And even within Altium, if you go through and you look at the Explorer panel, even there, it shows up in the parts request too.
Got you. So you can see what part requests we've got, the fact that they're kind of, you know, what state they're in, description, as you say, manufacturer part numbers, who they're assigned to, and this kind of good stuff.
Yep, and everything comes right up. So then Austin can go through, make the part, and then when it's ready, you just change the state to completed, and that's it. It's ready to go.
And we're good. So then it's just a case of going to your components panel, doing a quick search for that part, and just kind of drag and drop, and you're ready to go, right?
Yeah, it's really easy.
Cool. All right, awesome. Are you guys making use of the component templates feature at all?
Yeah. Yep.
Maybe talk to that real quick, because I mean, component templates always find, you know, if you want to make sure you have a real structured, kind of well-maintained and managed library, pretty fundamental to making sure that you can kind of follow standards and so.
Yep, and it's quite a process to go through and make component templates for every kind of component that's out there. So this is like an evolving process for us as we're gradually growing, maintaining, and kind of cleaning our database. But the way we approach it is if you go to manage content, templates, and then we have our velocity component templates, which is empty right now. Maybe it's down here. Yep, velocity models templates. Okay. So again, we kind of have been migrating how we're doing things. So there's two sections of our library right now. You guys get kind of our internal process at the moment. So bear with us a bit. But yeah, so these are the ones that we're going through, and like where the easiest place to understand component templates is in the example of like your standard size resistors. So there's a lot of ways that you can set them up, but the way that we do it is by the resistor and the size. So we have all our chip resistors here, and you got your 402, 603, 805, 1206, and you can go through and make templates for whatever components. But the idea here is now you can apply that template to the folder where you're going to save those models, and then all you have to do is put in the manufacturer part number and the specific value of the resistor, and it's going to assign the correct schematic symbol. It's going to assign the correct footprint. If in the future we need to make a change to our 805 resistor footprints, every single one of those is going to automatically get that change, which is just really, really nice for keeping everything consistent.
So you've no longer got this kind of like duplication of, you know, symbols, schematic symbols and footprints in places, you know, this nightmare of kind of like error propagation where you fix in one place and before you know it, 3 months later it's popped up, and I can see Chris smiling there because I'm sure he's been on the receiving end of these problems.
Yeah, exactly. And in particular, I would love to speak to that, because we see, like, with your 0603s and your 0805s, you can, you know, pretty much you'll be able to put them down and you'll be able to solder them. But when you start to get to 0402, 0201, 01005, they got to be dead nuts. And when we'll see it where we'll get 3 or 4 different 0402 footprints, and you're like, what is going on here? In the same design, yeah.
Yep.
And you go, well, these 3 are great, but then this one, I'm getting the tombstone defect everywhere, and you can tell it's just a messy library and it hasn't been managed well, and it just becomes a nightmare. And you go, how do these things happen? It's fun to see the behind the scenes of how you can manage a library properly.
So now you know, Chris. Now you know how it's prevented. But what goes wrong when you don't use systems like this?
Yeah, that leads me to a question, actually, Dugan. I know you had a day job before you started Velocity.
Mm-hmm.
Were they using a centralized library where you were working before?
Yeah. So I got to go through the wonderful experience of, like, we were there when we first bought Altium. And then we were using it with Nexus and Vault was what they were called at the time. I'm not sure if those products are still called that or if it's going to be switching over to this. But yeah, and then I spent 3 years building up that library with the templates, with, and then stuffing it full of all these wonderful parts. And then I left to start this and had to rebuild my library from scratch again. So yeah,
you knew
I did
exactly
have
how to do it, Dugan.
Yeah, no. I knew the right way to do it, and I knew how important it was. But still, I think it's every PCB designer's nightmare to lose your entire library and have to go through and rebuild it.
Well,
but
that's every manufacturer's nightmare too. we have almost 50,000 unique part numbers in our library right now. So we have backups of our backups of our backups.
I mean, for us, it was one of the main reasons that we became an Altium house was because of the access to the libraries.
Mm-hmm.
Well, the reason I ask, gentlemen, is because over the years here, I've seen most of the customers that we speak to all acknowledge that there would be significant upside in centralization of a library, standardization of library templates, all the things you just spoke about, Dugan.
Yeah.
But there tends to be a real aversion to actually going through the motions. And I really have 2 questions for you, which is, first of all, why do you think that is? And then the second part to that question is, how easy was your experience in migrating from individual libraries to a centralized library, either in your previous work or obviously at Velocity, you started with a clean sheet of paper and saw the value, I would assume, and just decided to start the business off on the right foot.
Yeah. So I think one of the things that's most daunting at the beginning of setting up how you're going to manage your entire company's library is how are you going to define your hierarchy? And the tempting thing that we've looked at before is we'll just copy DigiKey's hierarchy or Octopart's hierarchy or whatever that might be. But then you have to manage the schematic symbols themselves and the footprints themselves. And every resistor is pretty much going to have the same symbol, but they're not going to have the same footprints. So how do you set up that folder? It's just going through the motions of understanding how you as a company want to catalog every possible electronic device. And that's a little bit daunting. So this time around, a lot of what we did is we decided to closely follow Octopart's hierarchy as best as we could, because Altium obviously ties into Octopart really well, and we can pull in data from there. But yeah, I think the most daunting part of it is just figuring out how you want to organize that, because once you start down that path, if you change it, you then have to go through and change a lot of things, everything that you've already done too. So yeah.
Making sure that you kind of plan that from the outset saves you a lot of hassle a bit later on.
Yeah. Yep. So I think that's a spot where, well, when I was at Amway, someone actually walked us through going through and organizing all that and making recommendations on how to do the structure. And that's what I did at Velocity, just follow the same advice.
I noticed you mentioned the Octopart side of things there in terms of leveraging that. Could you maybe talk to that a little bit?
Oh yeah. So Octopart has made making components so much easier. And the big thing is to follow our standards now. You have to have the right symbol, you have to have the right footprint, and you have to have a 3D model. If the manufacturer makes a 3D model available, you have to use it to meet our standards. but there's a bunch of other parameters that are sometimes component specific too, that are then why you make the templates. But what's really nice about Altium working with Octopart is you can, I think, update me on the number now, but last time I checked, there were about 400,000 components that already had libraries and symbols for you to start with.
We're blown past 1 million now.
Past 1 million now. Yeah. Yeah. And yeah, most of the time we go through and we tweak the schematic or we tweak the footprint a little bit, but again, it's tweaking an existing library versus making it all from scratch. And that has really accelerated how easy it is to go through and make a component. So do you want me to go through?
And, that? Yeah, could you show us that in Altium Designer, how you do that? I think it's using the manufacturer part search panel, right?
Yes, one of my favorite panels.
Yeah, one of mine too. I love this panel.
Many people like this panel, Lee.
Yeah,
this is a panel that just every time I look at it, I go, "Thank you for all the hours you've spent."
It's the panel that keeps on giving.
Yeah, yep.
It absolutely is.
Yep. So let's go through and let's just make an op amp. How about that? So I'm clicking on my integrated circuits, and then one of my favorite things is you can filter by what components already have models available. So now I know that all of these are going to come in with the schematic, with the 3D model, with the footprint, with the data sheet. All the information is there, and the only thing I have to do is tweak it to meet our standards. So we were going to look for an op amp, right? Let's see here. Oh, I gotta put my stars on there. Oh, here we go. So I can click on the link right from there. Brings me to the TI data sheet for the op amp. And this is where I can go through and see if electrically does this fit my requirements for the design. And then what I'm gonna do is I can just right click and acquire it. And this is gonna go into our amplifiers section. So now it's downloading all the design data. It already comes in with the footprints for your 3 different types of densities. It already gives you the symbols there. And yeah, if I needed to tweak that symbol, I can just edit it right here and say, nope, this spacing needs to be like that. No one does it this way, but I'm just showing that you could. So save that, go back to my component. And then the nice thing about templates is if there were specific fields here that I wanted, we haven't set up our op amp template yet, but right. In other cases there are, like we require the manufacturer part number to have a specific field so it shows up in our documentation correctly. All kinds of those things. You have the option to suggest default values or force specific values or force the user to like punch it in. And if they don't type in that field, it will not let you release the component. And that's just fantastic. So like I can guarantee that all of our component libraries are complete. And then to release it, it goes through, it does a validation process. And that's where, like, if I had a required field that my company had defined that, let's say Austin or Ben had left blank, it would throw an error and prevent them from releasing it.
Yep.
But we can just say,
I was just going to ask about this, like, you know, how much of this do you trust versus how much of this do you vet? Because as a manufacturer, when we get footprints that don't match the part, we often wonder, you know, was this just drawn by hand and a calculation was done wrong, or was it somebody downloading a footprint from a repo and they never checked it to make sure that it matched? And I'm always curious about how much you trust, you know, a library like that versus how much do you verify it, and you know, is it the whole trust but verify thing or whatever? So
the first like 30 times I did that, I went through and verified everything because I was like, this is a wonderful tool, but it's too good to be true, right?
Right.
Like set off those alarms. But I have never had an issue with one of these footprints to date.
Nice.
So we
I
trusted
I
pretty
would
well.
agree with that as well. I mean, we did the same thing with some of our boards that we designed, and it was like, okay, we need to check every single one of these footprints because we don't trust what this cloud tool has given us, and it got to the point where we started to feel like we were ridiculously wasting time with checking everything. There's kind of a self-policing going on, right? If someone finds a problem, they report it right away, and so it gets taken care of and is addressed.
That's right. I mean, you've got the ability to report that error. I think even at the bottom of the manufactured part search panel, you've got the ability to actually say, look, we think we've got a problem here. But one of the key things that I will mention about this whole thing is that there's a pretty rigorous process in place when it comes to getting these things actually produced. So there's like triple verification that goes on between different people that are contributing. So it means that we basically got 3 individuals that end up checking each and every part that ends up being made. And then if they don't kind of agree on what that is supposed to be, part doesn't get through. So that really means that, it really helps filter out those human errors, which I think are the biggest things, that we end up making, is that we're trying to interpret something off a data sheet and we get a pitch wrong or some of the spacing wrong or whatever it is. And like you say, Chris, it's not until you get down to machine sometimes that you even know, you're trying to program it and then you're like, problem.
We ran into yesterday is one of our customers, they drew their footprint, or, I don't know if they downloaded it or if they drew it themselves, and they, it was a reverse view. Basically, they drew it as if they were looking at the bottom when they should have looked at the top. And it wasn't until, so we had to call the fab and tell them, stop, don't build these. We got to change it because they had to fix their footprint. And, it, happens, like I said, just happened yesterday.
Well, if I could also interject here, gentlemen, let's say, in fact, there is a mistake discovered and it is late in the stage or even early in the stage for that matter. If you are using a centralized library methodology like in 365, you would then have where used capability anyway. And then let's take that a step further, right? That you're saying now you're sharing those designs with the stakeholders like Rob and Chris. That's a dynamic file. That's not a snapshot of the design that they're accessing in 365. So those changes would be propagated all the way down to the manufacturing level if that's what you decided to do, if in fact you did discover a mistake.
Oh yeah, that's one of my favorite features too. Is like, okay, so here's the part we just used. But yeah, like if we use one component in multiple designs and then later on we get feedback from Chris that's like, hey, this footprint was a little bit difficult. Can you just adjust this? Because it's linked to the library, I can make that correction. And then I can propagate that through to everywhere where it's already used. And then obviously all future designs will also have that correction as well. And going through it's the tools item manager, you can run it'll show you the component status of all the parts in your design. You can see that they're all up to date, or maybe you want to force something to be an old version for whatever particular reason, you can manage that. But yeah, having it linked to the whole tree of the component status and all the footprints that go along with it is really powerful.
Maybe we could take a quick look at one of the components that you've actually used across the OSV design there, and just show us how with this centralized kind of component library, one of the really powerful capabilities, as you mentioned, is the where used. So actually, understanding, okay, well, what projects is this thing on? Yeah.
So let's go through and find 100 nano capacitor.
Pretty common one, this one. Imagine it's used in a few places.
It's going to be used a lot, yeah.
It's called the 0.1 mic, not 100 nano.
Yeah, you got to get that right.
If you drag that up from the bottom, Dugan, for some reason it's right the way down.
Right in here.
We'll just hit the on the far right, the 2 arrows that look like they're going up.
Yeah.
Hit that, exactly. And then drag it up so we get like a full width.
Yeah. So, yeah, this particular one. So, yeah, to Chris's point, this is a 402 capacitor. We want to make sure it's right, and we have it used in a couple of these different projects here. yeah, if we needed to go through and make a change to it.
To be clear, besides our homepage, the most popular page on our website is where I defined my favorite 0402 footprint. We get like
I'm gonna go make sure ours is compliant.
Every month we get like thousands of hits on this page.
All right, maybe we could move on then to talking about the release to manufacturer side of things. You know,
Yeah.
The biggest thing here in my mind is that when you get to the point where you spend all of this time in your design, you really want to make sure that you release that coherent set of manufacturing data. And Chris and Rob, I'm sure you've been at the end of receiving a fairly incoherent set of manufacturing data before, where maybe your drill file doesn't quite match up with the Gerber, or maybe you've got some pick and place information that in no way relates to the fab data that you've also received. Maybe you guys could talk to that a little bit, and we could explore how you're actually handling your release to manufacture process.
Sure. So this project, I've received permission from our client to show this off. I'm gonna stay away from the schematic side and keep this a little bit zoomed out, but yeah, you can kind of get the idea. But when we go through and we have all our documentation set, we've gone and made output jobs for the fabrication release, for the assembly release, and then we do an engineering release as well. That then is, well, meant for each one of those. So the fabricator, especially on a sensitive design, no offense, Rob, but you don't need the schematic, I assume, right? Yeah, that's so, yeah, that release package doesn't include the schematic. It only includes the drill files, the Gerbers, the net list, all the stuff that you need to make the circuit board. So on the manufacturing side, this is what our release candidate looks like. And this one hasn't been released yet. This is like our draft one. But within here, there's the fabrication, there's the sources, and there's the assembly. And I can go through here and send it off to someone. And they can, right from the web browser, they can get our prepackaged release. And then each time that we go through and make a design change, releasing consistent documentation is just a matter of like hitting release, and it'll regenerate everything. The file trees are all set up the same. The file names are all set up the same and follow the standards. Some of our clients request a specific output format for everything. And if we didn't have a clean way to manage that, we'd have to go through and manually change it each time. And that's just a lot of time, honestly. So being able to do things like this in a consistent and released way is really important to us.
The other key thing here is that when you do send this package to the manufacturer, like normally manufacturer's just going to receive a package like a big zip file. They're going to open that up and that's an Aladdin's cave of all sorts of kind of stuff that may or may not be relevant to what's actually needed. Probably versioned with something like new 01 or whatever that the name of those files might be called.
Final release part 2. Yeah.
Yeah, exactly. Yep. So, but obviously with this, you can click on that button next to send to manufacturer. And this is kind of going to give a very similar view to the view that the manufacturer is going to get when they actually receive the link to the manufacturing package that you send.
Yeah.
So to your point earlier, Dugan, schematics and sources are not included here, but this becomes a very should we say, manufacturing-centric view of the project.
Exactly. Yeah, and it's perfect for a demo like this because the schematic isn't even included in here. But you can still send it to someone, and they can see what the design is. And there's not a whole lot going on here. This is just a thermocouple card. But yeah, it's nice. I like to go through and add some stylistic things. So the block diagram from the data sheet that shows how these chips work, I just throw right on the silk screen. Call out the channel names. And then if you really want to make your client happy, just put their logo real big right on the front. If there's room for it, they love it. And then, yeah, the equation to get your outputs. And on the back, I get to, I put my little watermark, but I'm not the star of the show here. So it's just off to the side. And I give them a spot to write down the serial number and everything there. But,
well,
yeah.
I have a question for Chris and Rob. So first of all, you get extra style points from me, Dugan. It is I like those little touches you add to the card for sure. But for Chris and Rob, is it common for you guys to get otherwise manufacturable designs, but the documentation prevented the manufacturing or fabrication process from moving forward?
Oh,
Yes.
we could spend a few days going over the battle scars on there. You know, and it's everything from serialization processes and keeping track of date codes and lot numbers and different format requirements. You know, we have a lot of, and it's funny, but they're old military designs where they've called out a certain height, character height, and then they have a serialization format that ends up being about that long, and there's only about this much room on the board for it. And it's like, well, you have a conflicting requirement here. And as silly as that sounds, is we get boards rejected because we printed exactly what they wanted, exactly what the size they wanted, but it went outside the envelope that was listed on the board by 200ths of an inch, you know. And it's, again, these are the things that when we were doing the OSV, you know, I nailed those with Dugan right away. We covered them, and we had no marking issues.
Yeah.
Yeah, and we often see just like, you know, we'll see conflicting polarity indicators. You know, perhaps the schematic is saying it goes this way, but then the silkscreen says it goes the other way. And you're like, well, what are you supposed to follow here, guys? You know, and generally speaking, we just say, look, if the silkscreen says to go this way, then this is the way we're going to go. You know, and don't be overly concerned with the schematic, but that's bit us before too. So, you know, it gets tricky trying to make the right call. And ultimately what happens is we just say, well, you know, stop running. We got to call the customer and figure out what to do about this.
Now, do you see situations where obviously you make the customer aware of the documentation errors, but do you see examples of the same customer making the same mistakes over multiple projects because they're using a sort of an old school checklist release process versus an automated templated release process such as we have in 365?
Oh yeah, we basically have, like, you know, specific customers. Yeah, we know to ignore these things. We know don't pay. Like, we'll have customers that reference us to use like a particular flux chemistry or something that's been obsolete for 20 years. It's like, yeah, well, you know, we're not going to look at that.
So you're saying that you are the templated release process, Chris?
Yeah, it's in certain circumstances. Yeah.
Awesome.
Yeah, but it's really tough though in those kind of situations, especially when you have a, you know, really high controlling quality management standard. You know, we are AS9100. We're doing things for satellites and for space applications and military. So when there's a spec or something called out on a fab drawing or a note, you know, we, per our quality system, are required to account for that in all of our CFCs, all of our documentation. So when you have that kind of mistake, and especially if we don't catch it in the planning phases up front, you know, it gets 3/4 of the way through the factory and one of our quality technicians or one of the actual operators catches it. And it's like, oh, well, we might actually have to start the whole thing over because they called out this particular hot oil process that nobody's used for 20 years. And now the board doesn't conform. And now we got to go get a waiver and all this other kinds of stuff. It's just, like I said, we could spend a few days talking about battle scars from this kind of thing.
So why don't we talk a little bit about the manufacturing side of things? So, you know, by the time you kind of gone through all of this heavy lifting, well, actually you haven't gone through all the heavy lifting in the design. Actually, one of the key things is you're actually able to get in touch with the kind of manufacturing partners, you know, the fabrication, the assembly guys, a lot probably earlier on in the process than you ordinarily normally would.
Oh,
so
absolutely.
yeah, it'd be great to understand a little bit about how Altium 365 has kind of helped you go to manufacture and what that relationship has been between, you know, you Dugan, yourself, Rob, and you, Chris. You know, how did you kind of come together, and how was 365 kind of, how did it change the way you work, and how did it improve the outcome essentially to the open source ventilator project?
I'll jump in, Chris, to start, and then maybe you can follow in.
Yeah, that sounds good.
I think for us, the key was the point in the design process at which we were really intimately involved. We had been given heads up. The entrance into Altium 365 was extremely simple. I'll vouch for that. And we were able to get a look at the designs kind of right before the team was finalizing their layout and routing. So we had a pretty good indication of the board envelope, basic, I wouldn't call it, it'd be a little bit past preliminary component placement. And most traces had been routed and laid out. They were still working on finalizing where final placement was going to be and final actual copper layout. But from my perspective, it let me see right away where I was going to have challenges in the fabrication process. We were able to look at everything from solder mask dams to space and trace on lines, different component layouts and footprints that were going to have etching issues. And I could go through all of that before he even, his team had even started making fab drawings. And we got to the point in the conversation where we never actually had a fab drawing created because we had identified every note or every piece of communication that we needed to have ahead of time. And so everything from solder mask color, silk screen, board markings, all the little details that kind of tend to get overlooked and end up requiring back and forth communication between the fab house and the design team. We eliminated in an hour phone call and had most of that taken care of before the designs were even finalized.
So Rob, could you do me a favor and contrast that with what you would typically experience as a fabrication, board fabrication provider?
Yeah, it's really, I don't want to be too doom and gloomy, but our experience is that fab drawings, Gerber files, drill files, they're a communication tool. They require back and forth communication with the fab house and the designer to get intent conveyed. Almost every single new product that we fabricate requires back and forth communication. And because there's oftentimes a buyer and a purchaser and sales, involved in the process, and especially with larger organizations where you're not intimate with the design team, it can sometimes take 2 to 3 weeks before we get all of the back and forth questions answered. We got the back and forth questions answered before we even started working on the boards. And when we got the boards in to start the tooling process, I had all 5 of the OSV boards tooled and on the floor in a day.
Wow. Wow, that's impressive, Rob.
Yeah.
So would you say it's safe to say that this is what's really, what was enabled here was your real ability to be brought into the design process versus sort of at the end of the process where they just sort of flick you some design files, Gerber's, fabrication drawings, and say, it's your problem, you figure it out?
Absolutely. And, I wouldn't have jumped in and told Judy how excited I was about Altium 365 if I wouldn't have noticed this kind of collaboration happening with this project. And it was one thing with the open source ventilator, like Dugan said, that board and design was relatively simple and easy to put together. But when we're talking about some of the higher end cutting edge technology designs, satellite phased array radar, some of the new technologies that we're seeing, the collaboration has to be there because we just can't build when you throw a set of files at us with features on them that require less than 1/1000th of an inch tolerance, or when you have traces and spaces that are in the sub 25 micron range, right? These are not, board fabrications. They're engineering science projects,
Well, let me ask you this question, Rob. How much of that divide between you as a fabrication provider in the design and engineering community, how big of a divide would you say there is? In other words, are your customers generally aware or unaware of what's involved in the manufacturing process, and therefore really what's achievable from a design perspective that can actually be manufactured?
Well, I can vouch for me personally, and so I won't trash every designer out of it, but I was primarily in electronic design for 15 years. That was my job before I took over as director at Calumet. And I thought I knew the PCB fabrication process pretty well and how to make these different features. And I didn't. There was a ton of subtlety within the compensation processes, the different pressing processes, all the different chemistries that are used to realize certain features. I had no idea that artwork that was passed to the board house was completely modified in order to fabricate the boards. I thought they sent that artwork to their imaging devices and it just worked. And that's not the case, right? We take every single layer and we make about 8 different imaging layer sets out of that are all compensated and all adjusted for the differences that each of our machines and processes need to have to fabricate the boards. Last year at Altium Live, I think the CEO of Sierra Circuits asked the question of, how many designs go on hold? And he said, all of them. And that's really kind of what we see is there is a really large gap. There are some pockets, especially some real people who are pushing the limits of technology at a couple large OEMs and other companies that have like 1 or 2 super experts in the PCB fab process. But by and large, designers, they don't know what they don't know. And so they're under this idea that I can send you my electronic files and you just make it work. And really, especially with higher technology stuff, that's not the case anymore.
Well, Rob, perhaps they assume that because you more often than not make it work.
We try really hard. We try really hard.
I think there's a lot of truth in that.
Yeah, you got to walk this fine line of where do you recommend to a customer that they make a modification and where do you just ship it? How hard do you work to just make your customer happy versus going back to them and saying, if you made these changes, boy, you'd save us a lot of headaches. And then ultimately, in the long run, you'd save yourself a lot of time and a lot of money. And it's that fine, it's that dance you do around where do you make these recommendations versus, like I said, just ship it.
Yeah, we've had that same thing with, pointing out a process. Some people were adding these extra vias and via processes for heat sinking in the middle of a big pad, right? Which is the recommended practice. But we were able to recommend an alternate process, demonstrate the heat transfer that still was valid, and save 3 whole days of our manufacturing process and therefore 3 days worth of cost out of the boards.
Significant. Chris, what about from the assembly standpoint?
So Nadeem and his team, they honestly made it so easy. So where Rob was able to step in and he was able to look at the process using 365 and he had a lot of feedback and he had a lot of, he was able to, what about this? What about this? What about this? Really, the OSV team did such a great job in making these. Remember, Dugan said earlier, they wanted to make these as simple as possible for anybody in the world to be to assemble. It's an open source project. Dugan's not going to own it, Nadeem's not going to own it. And Rob and myself aren't going to own these things. We want to be able to have anybody manufacture them. And the engineering team did such a great job that I came in and I looked at it and I go, wow, this is all pretty much great. But there was one feature on the board that we looked at, and from an assembly standpoint, we knew because we've had so much experience with this that it was going to be a bit of a struggle. Yeah. So Dugan's pulling up this. This is the micro USB port. The past 10 years of stressed out engineers in assembly shops everywhere can attest to how annoying these parts are. Now it's a great part. I mean, everybody's familiar with them. They're probably in their cell phones and their Bluetooth speakers. But there's this little flange that we're doing a good job of zooming in here that dips below the edge of the board. You see how that flange is just sort of water falling below the edge of the board. Yeah. So not every designer knows that when these get assembled, that a lot of times the boards end up butting up against each other. So we don't just build these as single up, panels, single boards in and of themselves. We put them into a big array, big matrix to build them. And it's great to see these sorts of things and to be able to collaborate using products like 365, because we can immediately identify this as something that is going to be a problem during assembly and work around it. So it's really a process between not just the designer and the assembler, not just the fab and the assembler, but really the designer, the fab, and the assembler all have to be involved in order to make a part like this successful. Because we're able to point out to the designer, hey, if you make sure to have your silkscreen legend outlining that part, then Rob's team will see that immediately, and they'll know that they have to compensate for that sort of thing, and give us a little space so that we don't butt up the board right next to it, and have a problem with these USB ports being lifted up into the air. And being able to all jump in and all talk about that in real time, I mean, literally saved us hours worth of potential rework, because we've seen this happen before. Now I think we only built what was it, 5 pieces or 10 pieces, Dugan, but if we were asked to build 500 of these, we may have had 500 we had to rework. So it's great to be able to fix these things ahead of time. And like I said, the rest of it was really easy to assemble. It really wasn't that difficult. It was just this one thing we had to be prepared for.
Well, Chris, how common would you say this USB connector problem is?
I mean, this USB connector, everybody knows how ubiquitous this particular connector
Sure.
is. It's being, and these are designed by a consortium of teams, between the big companies like your Apples and IBMs and Microsofts. They all get together and they design these ports together. And because this plug was so small, they had to have this flange, this sort of a funnel to catch the port as the user's trying to plug it in. It's my personal belief that when the consortium got back together again for USB-C, everybody said, flange was a terrible idea. We've caused assemblers all kinds of headaches. We've upset Chris Denny. We need to change this because USB-C doesn't have this flange anymore, which I'm quite grateful for. But honestly, if we don't catch this ahead of time, I probably am not exaggerating that we've spent over 100 hours reworking these types of ports if we don't catch them ahead of time over the course of a decade,
Sure.
right? Maybe 100 hours, probably more. I honestly, hard to say, but we've spent an enormous amount of time. Oh, great, these are up in the air. We got to flatten them back down. Or we reach out to our customer and we tell them what happened and ask them if they're okay with it and if we can leave it.
Let me ask you this question, Chris. This is an interesting thought I just had, which is, so certainly with your expertise and with 365, your ability to be brought into the design process or much earlier in the fabrication or assembly process, you're able to look at a board and probably know exactly where those hotspots are going to be. There's a USB-C connector. Clearly, there's a potential for this flange to not be aligned correctly with the edge of the board. How many times have you seen customers make that same mistake multiple times because you just fixed it?
100%. Yeah, it's very high because we always just try to catch it. We always just try to be aware of it. And what helps is when customers, they draw, it looks like I can see here in this, that there is a legend, there is a silkscreen legend that goes beyond the edge of the board. And that's huge because then Rob's team can see that and Rob's team can know, okay, we have to compensate for this when we do the panelization. We got to make sure that this is being accounted for. And without that, it's hard to identify these things. Like look at the 2D view for a second, if you can. The 2D view, it's hard to tell that there's a USB port there, that 3D view is beautiful, but you see that yellow silkscreen legend coming out the edge. And that's a big red flag to the fab team to be aware of that.
Well, I would also highlight just for our viewers here and attendees of Altium Live 2020 that what we're actually looking at here is in fact not Altium Designer. This is exactly the view that Chris and Rob had as secondary stakeholders in this project, as assemblers, EMS provider, I should say, and fabrication provider. This is the view and the interaction they had with Dugan and the OSV team. I just thought I'd point that out because when we show this, it's often, many people take for granted that, oh yeah, you're looking at Altium Designer, but no, this is the experience that anybody that you wish to invite into your design process or assembly manufacturing process would have, simply with providing an email address.
Yeah, and I want to add on to that. I've been working with clients, showing them and walking them through their designs on an iPad using the same interface. And even on an iPad, you can flip through the 3D and zoom in and pull up the BOM and cross probe between parts, and being able to do that without having a full like workstation with Designer pulled up. It's incredible.
Maybe you could show us real quick, Dugan, just a couple of those things that you mentioned, like the cross probing is so simple and fluid in this.
Oh yeah. So check this out. So what I did is I selected that USB connector Chris was talking about. And over here, I just hit Schematic, and there it is. Or over here, I can just go to the BOM, and it tells me exactly where that is. I can click the link, and it's going to pull up the Octopart version of it. And it's all just right there. You can get the data sheets and everything. Even see. Yeah.
We can also cross probe to the 3D as well.
Yeah.
I believe, and this was a new capability that we added not too long ago, actually. But now there's cross probing and also component selection in 3D. So maybe you can just show the ability to now select something else. Yeah, exactly, just like this. And then the ability to jump backwards and forwards between all of these. Now, this is obviously a key thing that in Altium Designer we've had for some time. Bringing this kind of capability into the web. Maybe you just talk, just quickly about how that kind of like ability to navigate the design is really just, it's helping you guys.
Yeah. So recently we brought on a new electronics intern, and I love being able to go in and answer his questions when I'm not in front of my computer. I can just pull it up. Mm-hmm. I've got an iPhone 7. It's quite vintage now, and the screen's a little bit small. So I'm not going to say it works great on an iPhone 7. But on an iPad, yeah, I can just go in and see what he's doing, answer his questions, comment on things back and forth. It's really convenient. And I'm a firm believer that the more people that have visibility into a design, the better the design is going to come out. If it's just someone saying like,
the better.
yeah, we'll take care of it. It'll be fine. Like that process has worked for a long time. But like anything, it can be better. And this is one of the tools that we use to make it better.
And if I can just kind of comment on this real quick from a manufacturer's perspective of these types of tools, like for years, the way that we have helped our customers with their designs is like, you send the Gerber files over to us because maybe we didn't have a license to Altium at the time. And, we're taking screenshots and we're marking things up and we're writing paragraphs about different things. And then you send that email and you wait. And you wait and you wait, and then it comes back the next day or the day after. And so you have this extended timeline. You get all the answers done, but
or it doesn't come back, Chris.
Or you send it to me, Chris, and then I write that kind of stuff up. Then I send it back to you, and then you have to send it over to Dugan.
Right.
And again, it's a 3-week process before we've got everything sorted out.
Yeah, that's exactly right. And what I've even done in the
you've got all of that contextual commenting, right? So in here, for instance, Dugan can probably just really quickly show that it's not just the visibility of the, to the design, but the ability to mark it up, as Chris was just saying then. We haven't got this kind of now separation between the actual design and the kind of metadata or the thing that we're wanting to comment on with it. Which, as you said, Chris, when you're kind of taking screenshots and writing pages of text, it's pretty easy for these things to kind of just become a bit decoupled and from each other.
Yeah, it got to the point where sometimes I was just screen recording and recording my voice explaining something and then uploading it as a private video to YouTube because it was just the quickest way I could explain something. But yeah, but doing something like this makes it a lot easier.
A private video to YouTube.
Right. Yeah. Right.
Yeah.
Well, I have a question for you gentlemen. and look, obviously I'm familiar with what you're talking about, this back and forth ping ponging of emails, sticky notes, cocktail napkins, back of the envelope, that sort of thing we've all done. In 3-week process, can you contrast that with how long this took? Because and of course it's a bit of a loaded question because I know the answer, but I'd like for the viewers and the audience to hear the contrast, the significant contrast between the usual and what you experienced on this program.
Yeah. So the thing that's interesting about this project is you can't compare it to just how long does it take a team to put together a board.
Sure.
Because this was a brand new team developing the scope for the project, self-organizing, coming together, like figuring out what we're building, and then designing it together, and then like releasing physical designs to go and be made. And we went from like first coming together as a team to having this ready to be made all in about 6 weeks. And there were 5, I think there was a 6th alarm board or a 6th design that we needed to make too. But yeah, we went from nothing to an organization developing electronics and then releasing a first rev in like 6 weeks.
Well, I'm asking specifically about that. I'm going to call it a negotiation. When it comes time to actually fab and assemble the boards. And I know you guys talked about when we discussed the event, you guys talked about effectively getting on the phone, everybody in real time looking at Altium 365 and discussing through some of the fabrication and assembly issues that may pop up.
Mm-hmm.
Can you talk about that process? That's the process I think that Chris and Rob were referring to that take 3 weeks. How long did it take you guys in this example?
An hour. Yeah. We figured it all out in an hour. It was really easy.
Yeah. And honestly, I just kind of sat there and watched these guys work out most of the fab questions. And I was like, yep, the USB port. And then it was pretty easy for me.
Yeah, it's incredible.
Yeah. And we're going to touch more on that in our panel later on.
And I guess to be a little bit fair, is my microphone working again?
Yeah, you sound great.
Yeah, you're good.
To be a little bit fair, Dugan had sent me the designs ahead of time. So I did have enough time to kind of go through each of the boards beforehand. So I was loaded with some questions before we got on the phone. So if we count the hour to 2 hours I spent before, a total of 3 hours to get everything worked out.
Well, I mean, 3 weeks to 1 hour is a hell of a value proposition. But now that it's 3 hours, I don't know that our viewers are quite as impressed.
Right.
Exactly. Chris, you mentioned a bit earlier about having to do everything with kind of 2D data in the past, so that you were trying to almost kind of walking through with kind of like half blind, as it were. So you're not really 100% sure of what that end thing's supposed to look like. What kind of impact do you think this could have, just having everyone on the shop floor, just having access to, say, this 3D kind of capability in the browser, for instance? How do you think this could influence the assembly side of things?
Yeah, so recently it was pointed out to me that this is a freely accessible tool as long as you had the .pcb files. And so to answer your question, I will explain what happened to me yesterday. I did a Google search for Altium Web Viewer and saw that there was just a simple, upload your .pcb file, drag and drop, and then 30 seconds later, all of a sudden I have a 3D view of it. And I went around our factory floor yesterday and I shared this with everybody, and everybody I showed it to was just slack-jawed. They're all like, oh my God, this is amazing. Like, they were blown away, especially the folks working on our through-hole assembly process. So the SMT assembly process, there's always been, the 2D tools have always been pretty good. There's good standards for how to define where something gets placed and what its orientation should be, but there's always questions on the through-hole side of things. And when we were able to bring this 3D view onto the floor, and they were able to just immediately see, like how these through-hole components are supposed to go together and what orientation they're supposed to be in, it was like, oh, this is a game changer. This is a complete game changer. So if we get access, not every customer sends it to us, but if we get access to those PCB files, then, you know, we can see this 3D view. It was incredible. And the same could be said for pre-layout. So say that they just put their components in place and they didn't do their layout yet, and they came to us and they said, hey, what do you think about this layout? Then I can easily say, you know, oh, you know, those, I don't know, capacitors are too close to each other. We're going to have placement issues. Or I can say, you know, and having that 3D view, you know, there's a reason humans have, you know, binocular eyes, because 3D views are an excellent thing, right?
Absolutely.
I think a lot of designers don't really understand how on manufacturing floors and manufacturing environments, we don't always have access readily to computers to just pull things up easily. That's still working its way through manufacturing and assembly places as a whole. You know, a lot of times those environments are dirty and not super clean, and just having a monitor there isn't as accessible. Being able to put this on an iPad and have it be something that can be in a protected screen and transportable from station to station is huge.
Got you.
Yeah, we've been rolling out computers onto our factory floor for the past decade, and even today, you know, I would say only 80% of our folks have a computer within arm's reach while they're doing an operation. Because keep in mind, they may be working on a big machine, and that machine may be running, you know, not even a GUI interface. It may be like a Linux interface or something, and so, you know, they don't have ready access to these sorts of things. But, you know, being able to hold a 3D object in your hand, like Rob was saying, is it's going to be really nice. I'm really excited to be able to roll this out and get our people to start using it.
That is awesome to hear.
Yes.
Absolutely.
Well, if you recall last year, Leigh, you know, we played the Skyships video, which was an excellent example of exactly this. And they're, in fact, they have iPads at their stations on their factory floor where they're accessing Altium 365 to get those assembly instructions, get a 3D representation of the board.
Absolutely. So it's so much easier to build something when you know what you're supposed to be building. So maybe one of the things that we could talk about is, obviously, at the end of the day, we very rarely produce hardware these days that doesn't have some kind of software running on top of it, right? It'd be really interesting just to get, you know, how you've leveraged Altium 365 in the software domains, maybe the firmware engineers or the embedded developers. You know, a lot of the time, having, you know, in a past life come from there myself, getting access to things like Schematic when you're trying to do a board bring up to understand how something should be configured, all that layout to understand where you need to kind of, you know, cross probe or probe to figure out and measure something. That can be really painful. Just getting to that.
Yeah, no, it can. And so we've learned a few things there too, but like Nathan is our firmware engineer, and the first thing we go through on any project is like going through and assigning the pins, because on microcontrollers, like some pins have different functions than other ones, and you got to be specific about that. So we go through and we get that set up, and then we get all the test points set up so we can go through and probe and like put in his logic analyzers. And as that progresses through the design, the old way we used to do it is like, okay, well, the schematic's done, ship out a PDF, and then keep track of that PDF. And then everyone would have to like manage their own like access to that PDF, or maybe like you do it sophisticated and now it's on a shared drive, but everyone's like going through and then looking at that PDF on the shared drive. It's like, okay, that's fine, but now like the client needs access to that too. So put them on that shared, like it gets cluttered very quickly. And the way that we're able to do it now is the design that is like in progress, we access that through the web browser. But for each of the previous releases of that board or of that product, those are each their own release, managed release. And you can go in and check the schematic at that time. And you get to see when that was released, what was the BOM at that period of time. Like being able to have all of that in the web browser where you can manage who has access to the projects. You have all the projects that you're assigned to available to you. It's just really, really simple. And you don't have to worry about like someone checking the wrong version of a PDF. It's all just right there. So yeah, it's the biggest advantage of Altium 365 for my organization is that we can get more eyes on the electronics design than just the people who are designing the electronics. The firmware engineers in there, like me now, a lot of what I do is reviews, and like some of the like more sophisticated designs we do, that's where I get involved. But a simple microcontroller project, I'm going to hand that to Austin, and I'm going to go through and double check everything. But honestly, a lot of that I can just do from the web now, or I can do that on the road, or like I can be at a client's office while he's doing like his stuff at the design station. And I don't have to fire up the full version of Altium anymore, but I can still have the exact right amount of visibility into the design wherever I am. And
So
that has been like the biggest game changer for us.
So no more manual cross-probing with sheets of paper across your desk, flicking from one thing to the other with a highlighter pen.
Yep. Although like, so whenever I talk to a new client, I tell them like, this is how we do things. Like part of our like process here is we're going to rope you in. You'll have visibility into this. You'll see the 3D renderings. Like when you get the board delivered to you, it will not be a surprise at all. It'll be what you saw on the screen. You just get to touch it now.
What's the general reaction of your customers, Dugan, when you talk through that with them and or show them an example?
Yeah, it's not just like, they're not just impressed with it. It's like jaw dropping to them. And then we start the project, and then they print out all the PDFs that I throw in my hands. So that's still happens.
It's going to take time.
It's a learning curve for sure. But at the very least, even if our clients like don't adopt the new technology and start using it right away, they know that we know what we're doing, and they know that we take managing their data seriously, and they know that we have a process that allows us to be really efficient. And that's like the hidden value. It's not even hidden. That's like the value that's right out there on the billboard, honestly.
Right, sure. Well, and you're using also obviously first-class modern tools. It's all perception of your organization, I would assume.
Yeah, we use SolidWorks, we use Altium. Yeah, it's the way to do things now, and we're able to deliver a lot of value to our clients using this kind of software.
I would like to thank you, gentlemen, for giving us a really, quite frankly, a sneak peek behind the scenes. I think, as I've said many times, and I said in the first bit of this keynote, you know, we've seen this divide between engineering and manufacturing growing. You know, nearly 85–90% of our customers now are, in fact, electrical engineers. And I do believe that as that trend increases, this divide has a tendency, or potential, I should say, to continue to increase. And really, one of the major goals behind Altium 365 with Altium Designer is really to connect, you know, the engineering and the designing community with the manufacturing community, and really get the benefits that we discussed through this keynote. So thank you very much for that insight. I think it was really eye-opening for me, and I hope for many of our attendees and viewers today.